Okay, so let's talk a little bit about the course objectives here. So this top group is sort of the more traditional things that we kind of expect you to learn and be able to do in this course. So by the end of the course, you should be able to explain the machine level representation of data and code. That's sort of the first thing we're going to talk about. You should be able to summarize the architecture of a computer, so how it is built and how all the components work together. And we mean both hardware and software in that architecture. You should be able to explain how complex systems are built from simple components. We expect you to be able to translate high-level code in C into assembly and machine language. And we expect you over the course of the programming assignments in this course to be able to write code to emulate the functionality of a computer, because if you can code up how a computer works, that gets you that demonstrates that you understand how it works at the lower level. These bottom objectives are a little more sort of self-development skills that are less about what you learn, not particular pieces of knowledge that you take away, but things that you will learn to do over the course of this semester. So the first one is to cultivate a sense of control over computer systems. Up to this point, the computer may have been something that you didn't really think about as something that you had complete control over. You may have just been sort of using it to do various things. And I hope that by the end of this semester, you really feel like you have taken ownership over using the software and the hardware in your computers. I hope that you gain an appreciation for software development tools. We will be writing a good bit of software in this course, and I hope that you will learn some of these tools along the way and gain an appreciation for them. I hope that you develop a sense of play when writing code, and by this I mean that I hope that you will not be afraid to experiment. Often in this course, when students ask questions, my response may include, let's go try it. Let's go see what happens when we try this thing that you've asked about. And so I hope that you will allow yourself to experiment and to play a bit. And finally, to appreciate the complexity of systems level software. These things can be quite complicated, and this semester we're going to start peeking into that. So yes, the top objectives are important, but I do want to highlight these as well, because they're things that you may not have thought about too much as being goals for this course. So this course is the first of our systems sequence at James Madison University in the computer science department. So this is where we are right here. These are the units that we'll be talking about. So we'll spend a few weeks learning C and Linux, if you haven't already had some experience with Linux. We'll spend a couple of weeks talking about how to represent data and programs in binary. We'll spend a couple of weeks learning assembly and machine code. And then we'll spend the latter half of the semester spending a couple of weeks learning about computer architecture and how computers are built, and then a couple of weeks talking about operating systems concepts, where the hardware and software kind of come together in this level of systems software that allows the software to interact with the hardware. So that will be the first course in the system sequence, where you'll learn the fundamentals of a digital single process system. And just as sort of a preview of what's coming next, the second course in the sequence, CS 361, is sort of a lot of the same concepts, but extended to multi-process systems. So you'll start thinking about all the complexities that come up when you start running multiple processes on the same system. And then from there, you will get to choose your own adventure and to branch out and pick one of or at least one of the advanced systems electives. And we do this because there are a lot of different kinds of hardware and software systems that you could take a deep dive into. And we want to give people the freedom to choose the particular kind of system that interests you most. And so there are various choices. The four that I have listed here are compilers, CPU architecture, operating systems, and parallel and distributed systems. There is also now a networking course, which isn't pictured here, but all of those are valid options for the last course in the sequence. So that's what's coming up for you in the systems sequence. I want to talk a little bit about what this course is not. just to manage expectations. So this is not Programming 101. I will assume that you can program. If you've taken the intro sequence here at JMU, you probably know Java pretty well by now. But I assume that you have learned some programming language in the past. And we will spend a few weeks learning C. So I will expect that you will be working to translate that knowledge that you learned about programming from whatever language you learned it in to learning C. This is also not Electronics 101, so we won't be going that deep into the hardware. We're not going to be talking about voltages and resistance and things like that. But if you're interested, those things are taught here at JMU, and I would suggest that you check out these physics courses if you are interested in learning more about the electronic side of all of this. This is also not Linux 101. I mentioned that we will be using Linux this semester, and it will be imperative for you to learn a little bit of Linux if you haven't already. We will be doing a little bit of that in the first part of this course, but you may wish to improve your skills in Linux even outside of the course. And so for that, I will point out that we have a very robust Unix users group here on campus that is devoted to enthusiasts who like to work with Linux and would love to teach you things about Linux. They generally have install fests and weekly meetings throughout the semester. And so I will direct you to their website, the jmunixusers.org. I am a co-advisor for this club, and it's a fantastic club. I strongly recommend that you check it out at some point. This is also not an easy course, and I say that just to manage expectations a little bit because students have given us a lot of feedback in the past that you do need to make sure that you carve out enough time to work on this course. This is not something you can just sort of spend a little bit of time each week and do well. You do have to put in the time. But I will say that you can handle it, and I know you can. You do need to be prepared to read and work a lot. Don't be afraid to experiment, like I said earlier, and it is important to have what we call a growth mindset. So when you run into something in this course that you are unable to do, which is going to happen, and it's going to happen frequently, I hope that you will not take that as this is a thing that I can't do, and therefore I am just going to fail. That's a fixed mindset, and what I hope that you will sort of be ready to do by the end of the course is whenever you encounter something that you're not succeeding at, that you are able to stretch and to grow into that so that you can do the things that you may fail at the first time. And I'm here to help you with that so that you can develop that skill. So some things in this course are worth memorizing. So when we talk about powers of 2, it's worth memorizing those. Hex to decimal translations, things like that are just things that hopefully you'll have memorized after a week or two of using them. For many other things, I'm not going to be asking you to memorize like entire instruction sets, things like that. Google is your friend. Go find things online. We'll be using Piazza, which is a Q&A forum online. It integrates with Canvas, and it allows you to ask questions and to answer other students' questions. So this is a great way for us to share information and for you to get help from not only me, but the other instructors and TAs and the other students in the class, and not just your section, but all of the sections. We've heard a lot of feedback in the past that it is very important in succeeding in this course to make sure that you do stay on top of all the assignments, keep track of deadlines, start assignments early, and ask questions whenever you get stuck on things. But again, I'm here to help. I am here to guide you through this course, and as long as you put in the time and effort that is required, you will succeed, and you will do well in this course.